Hello everyone and welcome to the webinar. This is Sydney speaking, and today's webinar will be dealing with the toolbox that we have inside 2.5D of SolidCAM. And what I'd like to actually put an emphasis in this webinar is that the toolbox actually is a canned program. It's a canned program of SolidCAM itself. It actually comes to make your programming time in many cases a lot quicker because it uses specific canned parts or say shapes that you may normally come upon in every single day life, and it just makes the programming go a lot quicker. For example, take your typical CNC machine. We're talking about CAM program. If you take your typical CNC machine and you're drilling a hole, you get usually use a G code of G81, G82, G83, so on and so forth. And when you do that, actually, that's really a canned program. You're just telling it a specific code. The CAM program behind the scenes is actually giving you G1, G0, G1, G0 going back and forth, and so on and so forth. And that's actually what a canned drilling thing, a canned operation inside the CNC machine itself does. Well, that's exactly what Toolbox is inside SolidCAM itself. It actually takes a specific type of operation, and you just give it some specific type of parameters, and when you give it these parameters, whatever happens, we do stuff behind the scenes, things you don't have to see to give you your tool path. You just give the minimum amount of parameters and the tool path, you'll get exactly the way you're supposed to get it. And that's exactly how Toolbox is. And again, it's supposed to make your life a lot easier and actually program your part a lot quicker itself in these particular cases. So let's actually get started with the webinar itself. And I would like to remind everyone that there is time for questions at the end. If you do have a question, all you have to do is click on raise hand. And again, all you have to do in the question area is write down your question. And when you finish writing down the question, don't forget to click on the send button. By clicking on the send button, I'll actually be able to see the question at the very end, and then I can answer the questions that you send. Okay, so let's get started with the webinar itself, and let's go. Now, what we see here actually is a particular part. I'll actually be programming two different parts. What we see here is a part that I'd like to actually program just about all that we see over here using Toolbox. Okay, so I'm going to actually be showing you during the webinar different toolbox options that we can use almost in everyday types of use. For example, if you take a look at the part, we have these large slot going across the very top over here. We have these smaller closed slots over here, these wider closed slots. We have O-ring options. We have corners over here to have to deal with. And I'm actually going to use the toolbox options, the toolbox cycles, in order to program this entire part. Now, going into the toolbox, we have inside 2.5D the option of toolbox cycles. Now, before I continue with the part itself, let's take a look at what we even have over here. Let's just open this up, and you can see we have a total of 24 canned cycle toolbox cycled operations to make your programming go a lot quicker. So if you have a wide slot where you want to use a spiral cut going through the middle, you can choose that. You have another wider slot where you have the trochoidal going in the middle and then clearing off the edges. You have those. You have for open slots, one end open. You have for wide slots, additional step-down slots. We even have, for spiral pockets, O-ring operations. All of these different types of canned programs are here available to make your life a little easier. Now, what I'm going to do is, like I said, I'm not going to use all of them over here, but I'm going to use many of them that you may use in everyday occurrences. So, in this particular case, I'd like to start off by machining this particular slot going across the part. Now what I'd like to do first is I'd like to take an end mill, but an end mill that has inserts on them, and go across just the very middle of this slot over here, just to open it up. So for that, we have a ToolBox cycle as shown over here, and the one I'm going to use is roll into an open slot. Now, why are we going to actually, you can see now the edges that I will have to choose as my geometry. And over here we see the actual tool path that's going to give you. You can see it's going to go actually down the middle, but it's also rolling into the slot itself instead of going straight into the slot. Now, the reason why we have an operation like this rolling into this slot over here is because when speaking to the tool manufacturers, such as, I'll give you an example. For example, ISCAR. We have tool manufacturers where they have end mills that have inserts in them. It's mostly and mainly very highly advised that when you use those inserts, not to go straight into the slot itself, but actually curl into the slot. This way you have a gradual build into the slot itself, avoiding that little that original bang going into the material itself. So this is what we have. This is why we have what we call the roll into open slot. Now, choosing the geometry, as you can see in the picture over here, we need to choose the one edge over here and another edge over here. The direction does not make a difference in this case. So create our geometry, and the geometry that I'll be creating will be this edge over here. That's one chain. And my second chain will be this edge over there. That's my second chain over there. Now, the tool that I will be using will be a 16 millimeter end mill. Then I remember I just said before that it's using, I'm using one that's particular that has slots on them, that has the inserts on them, sorry. My levels, my upper level will be the top surface over here, and my depth will be on the surface over here. Now note, the tool path, as I said, if we go back to the geometry, is going down the middle. In other words, I didn't have to create a sketch going down the middle. It automatically figures out what's the exact middle between those two edges over there. Okay, levels we did. Now let's go into our technology. In our technology, there's really not much we have to do here. That's the whole idea behind ToolBox, that there's really not that many parameters that you have to deal with. You deal with your step down, how many times you want to step, how far you want to step down each time. I'm just going to leave it at 0 this way. It does it all in one shot. And we have something else here called approach distance. The approach distance is as follows. If you take a look at the diagram over here, we're going to be rolling in, but we don't want the tool to go exactly to this point, coming down from the top, right next to the part itself. We want to come in a little bit from the outside to that point and then roll in itself. So that's the actual approach distance as shown over here. I'm going to put it at 3 millimeters just so that we can see it very well during our simulation. And even if I want, by the way, I can also do a floor offset, where a floor offset that it doesn't finish the floor, doesn't go all the way down. But I'm just going to leave it the way it is. At the very end over here, we also have an extension. How far out do I want the tool to go from the edge itself? Let's run our simulation. And if we take a look at the simulation, and we'll show the actual tool itself as well, you'll see that the tool goes down. Let's take a look at the very top view over here. And you can see that's a specific distance away from the edge itself. That's the 3 millimeters that I told you that's going to come in instead of 0. Now it goes to its roll-in point. And by the way, in the G code, you'll see G1 as it goes from here to here. And now it's going to actually roll in. Let's actually deal away with the tool so we can see the actual tool path. You can see now that it rolled in to this point. Then it just goes across to the other side as shown over here. And that's all done. Let's see this together with the tool itself. You can see the tool comes up to this point over here, past 10% past that edge over there, and basically we're done doing that slot over there, as shown over here. Okay, now my next step that I like to do is I like to have a pass on this face over here as well as this face over here. Now, the way you would normally do this in a profile operation, you can do one of two things. You can take this edge, you can do a regular profile on this edge and pick on this edge over here. In other words, picking two separate chains, or now the problem with picking two separate chains, not really a problem, but when you get to the end over here, when it goes over to the next edge over here, it goes up in the air to its clearance level and then comes back across over here, then come back down. Now, if you didn't want it to do that, if you wanted it just to go from this edge, then when it gets here, just go across over there, you would have to create a sketch, and it would have one geometry according to that sketch where it's extended over here. For that, however, we've added the option of in ToolBox. Let's see exactly what I'm doing. I'm just going to do a simple save and copy. And instead now we have an option here called Simple Slot, where I just pick those two edges, and the tool path will be exactly the way you see it over here, going across one edge over here and staying down, going towards the other side and then coming back out. In this particular case, I'm going to use that same geometry that I had before. No problem using that geometry. I'm going to use even a different tool now. Let's use a 10mm end mill for that particular wall. We have our levels, same thing as before. And now in our technology, we have the following. How much do we want to step down each time? Okay. And if we want to have an offset from the wall itself, let's say I want to leave 0.2mm on the wall itself, and if I want, I can also finish the wall. Now we also have an extension over here. In the extension, it just says how far past the edge over here do I go out before I go over to the other side. Let's run our simulation again on the part itself, and we'll do this one step at a time. You'll see now that the tool comes down. You can see the material that's left over there. The tool will come down, go across the edge, as shown over here. Let me just zoom in a little bit over here as well. Go across to the other side without going up in the air, going back down on this side, and finishing off that edge over there. Now it's going back and doing its finish cut. The finish on the wall itself, staying down, and then going back across the other side, and that's finished. Now this is all done all in one operation, and note you have very little parameters that you have to deal with over here. Okay, now next thing I like to do is I like to work on these corners over here. I like to machine out the material over here, around here, up until the step, as well as this corner down here. Now, if I were to do this without ToolBox, there are two ways I can do this. The first way was to do a profile operation over here, but by doing a profile operation, I would have to use the option of clear offset. Now, if I would do clear offset from this edge over here, my tool pass would actually be exactly this length over here, but throughout this whole area over here as well. So I would actually end up having a lot of air cuts. Now, another way I can do this is using a pocket operation. But in order to do a pocket operation here, I would have to create a sketch closing off these edges over here. And then in the geometry itself, when I create that chain, I would have to mark those two as open edges. So for that, we have the option inside ToolBox called Simple Corners. And let's take a look at the Simple Corners option. We'll use the option, as I said, Simple Corners. Okay, now in the Simple Corner, as you can see, I have to pick just the inside corner itself, just the inside geometry itself as my chain. This and this corner, the actual corner itself, is automatically closed by itself. Now what's important though is the direction of my chain, because it closes off whatever's to the left side of the chain itself. So the direction in this particular case is important. That's why we have an arrow showing it on the actual diagram over here. So let's continue now with creating my geometry. My geometry in this particular case will be this edge over here, this edge over there, as well as this edge over there. That's my entire geometry. Note, I do not have to close off the edge at all. The tool that I will be using, let's use my, I'll use my 16 millimeter end mill. My levels, I'll have my upper level over here, my depth up until that surface over there. And let's go into our technology. In my technology, I have, if I want to do a rough, if I want to do a wall finish as well, how much do I want to step down each time? Do I want to step down? Let's step down every, say, 5 millimeters, okay? We have our step over. How far do I want to step over each time? My toolpath link, do I want to go one way, keep on the same direction, or do I want to go back and forth? Okay, so let's take a look exactly what we have here. Run my simulation, and I'll do this one step at a time. You'll see that the tool will go down and clear off the entire edge over, as shown over here. And note, let me just do this very quickly. You'll see that it's actually machining down that entire edge over there, going in one direction in my case. And you'll also note the tool pass itself. Let's just get rid of this for a moment. You'll note that the tool pass is only up until this edge. If I would have done a profile operation with a clear offset, then my tool pass would have been just the exact same shape as shown over here, but it will also be that way over here as well. So you'd have all this extra air cutting over here, which you do not need to do. Okay, now wait, let's go back. One thing I did forget. We have to do this on 4 edges, not just on 1 edge. So for that, nothing to do with ToolBox right now, but we have the option of transformation inside the operation. I can do that over here as well. Let's just do a quick rotate of the part itself. So we'll do rotate. Let's do list. And I'll say, okay, let's include the original. We're going to rotate it 90 degrees. And besides the original, we want to add 3 more instances. We'll click on add. And you can see we have now a total of 4 instances over here, which includes the original. We'll click on OK. Run my simulation. And you can see in the simulation itself, let's do the solid verify simulation. You can see that it's clearing off all 4 edges as shown over here, going down to the bottom of all 4 of them. Okay, now, like I said, I still have to do the same for the bottom over here. What do I mean by the bottom over here? No, this area over here, from here down over here as well. I can use the same option of simple corner for that as well. I'll just do simple save and copy. So I'm keeping all the relevant information still inside simple corner. When I do that save and copy, I even carry over with it the transform as well. And I'll just choose create a new geometry. My new geometry will be this edge, and this edge over here. That's my new geometry. I'm going to keep the same tool, and all I'm going to do is go into my levels and change my level. My upper level is over here, and my depth is up until the bottom over there. No problem at all. Let's run our simulation, and you can see in the simulation that it does the bottom just as well, the exact same way. And of course, since I still have the transform, it's doing that as well. Okay, let's continue now. Now that I finished those corners, what I'd like to do is let's start working on these closed slots over here. Now, in this particular case, what I'd like to do is I'd like to use a tool that's the exact width of the slots itself. In this particular case, it's a radius of 3 millimeters, so it's a 6 millimeter wide slot. So I'm going to use a 6 millimeter end mill, and I'd like to mill this out by going down the exact center. And the way the tool path I like to have is that it actually zigzags as it's going down. As it's going across, it's also going down at the same time at a specific angle. So let's see how that's done. We'll choose a new ToolBox cycle, and this time we're going to use the option of close slot as shown over here. The geometry is going to be the following. I'll use the option of curve propagation just to click on this edge over there. It takes the whole thing. Same thing over here. I'm going to take all of those edges. Now, the reason why I'm not doing a transform in this particular case across over here is very simple, because they're not evenly spaced. Okay. And do another curve propagation over here, as well as the very last one over here. The tool that I will be using, as I had mentioned before, will be a 6 millimeter end mill. Now, my levels, my upper level in this particular case is over here. My depth is to the bottom over there. And if I want, I can even give it a little bit of a negative delta, so it goes a little further down. So minus 0.5 millimeters. Now, if I go into my technology, all I have to deal with is how much do I want to step down each time. Let's just do it every 3 millimeters. What's going to happen actually is as it goes across, it's also going to go down 3 millimeters. That's all I have to do. And note, I didn't have to choose a sketch in the middle. It automatically knows to go directly in the middle of it. Let's run my simulation. And as we see, I'm going to do this one step at a time. Let's zoom into this area over here. And as you can see, the tool is going down. And as it goes down across, it goes across as well. You can see it went down to its -8 level. It started at -5, now it's at -8. Another 3 millimeters after that, when it goes back across to this side, now to -11. As it goes back and forth into each section until it reaches the very bottom of 20.5, and then does one pass to clean the bottom. Of course, it does this on every single one of those slots that I showed over here. And you can see the actual tool path going down in a zigzag format. Okay, now, what I'd like to do next in this part is I like to do these slots over here. Now, these slots, I don't want to do the same way I did this one. This one I went down with the exact same size of the slot itself, so just going back and forth. In this, I'd like to actually go in with a smaller end mill and then clear off the walls in a profile manner with a clear offset in the profile, or more like a pocket manner. Well, for that, we also have a specific option inside our toolbox cycle, and that one is what we call additional zigzag slot. We'll choose my geometry. In this particular case, I'll just click on curve propagation, take that edge over there. It takes the whole thing. Again, curve propagation, click on this edge over there, and it takes the whole thing as well. The tool, let me choose a 10 millimeter end mill. And if I go to my levels, my upper level is this surface over here, whereas my depth is down to the very bottom over there as well. Now, in my technology, we have the following. We have our step down itself. I want to step down, say, every 5 millimeters. And then we have our ramping width. Our ramping width is not what's going to happen. It's going to zigzag down at one end and then go across the other end. And then again, zigzag down and then go across to the other end over there. This is the actual step down, the 5 millimeters I was talking about over here. The width of this zigzag that we're showing over here is over here, 20 millimeters. We also have a maximum ramp angle. What's the maximum angle that I'm allowing myself? Okay. let's just do, now of course we have also, besides that, we have our step over. After we've cleared the middle, how much it's going to step over each time. And we have a wall offset, and if I want, I can do a finish as well. Let's just leave it exactly the way it is right now. Run my simulation, and we'll see the following. Actually, let me do it right now without the solid verification so we can see the actual toolpath. And I'm going to show it also without the tool, so it'll be a lot easier to see the toolpath itself. Flip the part around a little, and here we go. You can see the toolpath goes down, goes across, zigzagging back and forth that 20 degrees. Note that when it gets to that first step of 5 millimeters, then it goes across to the other side. Now, once it reaches this side over here, it'll continue going down in that zigzag manner until the next step. And it does this until it gets to the very bottom over there as well. Now, once it gets to the bottom, then it starts, as you look from the top view, you can see it starts actually clearing around the side over here in a sort of a pocket formation. Gets to that edge, keeps on going down, let it run, and that's all we had to do over here. In this particular case, this was enough. Let's just show it now with the solid verify. You can see that it cleared off that entire thing, in that entire slot, as well as the slot on the other side. Okay. Now that I finished those slots, we showed the narrow slots and the wider slots over here. The next thing I'd like to do is, you know what? We still have to deal with these areas over here. Now, these are actually evenly spaced walls between each other, which are used for O-rings. So we have a specific operation called O-rings. Now, the way I used to work, the way I like to work at least, is that I would go into here with a smaller end mill. Let's say the width between this edge and this edge over here is a total of 4 millimeters. So I'd like to go in there with a smaller end mill, say a 2 millimeter end mill, go down the exact middle of that slot in a helical fashion, and then once I'm finished the middle, then I'd like to go off and clean one side and then the other side as well. Okay, just one moment. Now, when I do that, we can use an option here inside 2.5D ToolBox cycle, something called O-ring. How about that? Now, when I use the O-ring, like I said, it's going to do exactly what I said it's going to do. It's going to go down the middle. Now, the way I used to have to do this, used to have to create two separate operations. One with a geometry going down the middle, and then another so that the tool can go down the middle itself, and then another operation where I would clear off each wall in a profile operation. And then in order to arc into the wall, I would have to figure out exactly what is the proper arc to use in order to get into those areas itself. But this is now done all in one operation of O-ring, and I don't even have to calculate myself, figure out myself what kind of radius lead in and lead out I need. It does that automatically by itself. Let's see exactly what happens here. I'm going to use my geometry. Now note, my geometry is going to be this. Let me use the curve propagation option over here, as well as this over here. Now, I'll accept that. My tool, as I said, is going to be a 2 millimeter end mill, as shown over here. Okay. We have our levels. My upper level is the top surface over there, whereas my depth is that surface over there. Total of 3 millimeters. And my technology, we have the following. In our rough field, we have our step down. How much do I want to step down each time? Let's go every millimeter down into the part itself. Now, actually what's going to happen is as it goes around, it's going to go down as well. So the first time it goes around, it's going to reach depth of -1. As it goes around again, it'll reach depth of -2, and so on and so forth. Okay, now, I can also control it by a approach angle as well, by angles as well. Now let's do the next. We will also like to do a wall finish as well. Okay. Now note it's not asking me for any kind of lead in and lead out. That's done automatically. It knows the tool. It knows the diameter of the tool. It knows the width of the slot. It knows to figure out the exact radius that it needs in order to lead in and lead out. Now, in addition, since I need to do this on both of them, not just one of them, I'll also do use the option of transformation here as well. Again, rotate list, and this time I'm going to do a total of once at 180 degrees, adding one more to the original. Now let's see what the results of all this is. Run my simulation, and we'll see the following. You'll see the tool goes down. Sorry, you don't see the tool, so let's start it again. You can see the tool going down, as shown over here. Let me just flip this around a little easier so you can see it a little easier. And right now it's at a depth of 0, and it starts going across at the bottom over there. Now note, as it's going down, it's getting further and it's getting deeper and deeper. Now when it gets across the edge, now it's past that 1 millimeter mark, again going down to the very bottom. You'll note in a moment it's going to reach 3, and it's going to stay now in 3 to clear off the very bottom of that floor itself. Now let's bring this back to the top view so we can see exactly what's going to happen over here. I'm going to get rid of the solid verify so we can see this a little better without the tool itself. And what's going to happen now is as follows. The tool is going to arc in to this side over here, come out, and then do the other side as well. It also automatically calculates what kind of arc I need to lead in and lead out. Of course, it's going to do this as well on the other side as shown over here. Let's just do the simulation on the entire part. And we'll run this from the very beginning. You can see everything is being machined out on this part over here exactly the way I wanted it. Now I'm going to load another part, and we're going to continue with some more options that we have inside ToolBox. Now the ones I picked out are specifically ones that I know that many people can use them on a daily basis over here. So I'm going to choose a new part. I'm going to open up another part that I have over here. Yeah, that's the right one. Now, the first thing I like to do in this part is we have here a thin wall. Now, at this moment, there's excess material on either side, and I like to actually clear away the material on both sides. But however, since this is a thin wall, I don't want to clear away all the material on one side and then all the material on the other side, because if I do that, the moment I clear away all the material on one side, there won't be any support on this side. So if I machine this away, as I get further down, it's going to start bending this wall over here. I run the risk of bending the wall, and I'm going to run the risk of also vibrations as well. So what we have here is a specific operation inside our ToolBox cycle for thin walls, and it's called thin wall machining. Now in thin wall machining, again, the geometry as shown over here are going to be these top two edges. So I'm going to choose those two edges. The direction, again, does not make a difference. Same as that. And I'm going to choose my tool. The tool that I'm going to use in this particular case, let's use a 16 millimeter end mill. Okay. By the way, if I were to choose the wrong type of tools, like for instance a spatula, which is not appropriate for this, it will tell me the tool type is incorrect. Okay, so I do need an end mill. And we have our levels. Our levels, my upper level is going to be over here, and my depth is going to be over there. Now let's go into our technology. In our technology, there are two separate type of strategies. One strategy is called alternating steps, and the other one is called supporting steps. Alternating steps is specifically made for clearing away excess material that we may have on either sides. We'll see exactly, I'm going to explain it more as I show you the simulation. You can see it a lot better there, and you'll understand it a lot better there. But let's just choose right now alternating steps. Step down, how much do I want to step down each time? Let's step down every 5 millimeters, and then we have our clear offset, just like in a regular profile operation. How far away do I want to start from the edge itself? Well, if I'm not sure, I can always click on offset and click on this edge over there, and I'll get the value over here that I need. I can actually make this smaller if I want. I'm just going to leave it exactly the way it is. And I'm going to give it a wall offset of 0.5 millimeters to leave that for a finished cut later on. Let's run a simulation. And I'm going to run my simulation so you can view it in the side view using Solid Verify and viewing the tool at the same time. Now let's do this one step at a time. You see the tool will come down as shown over here. And now it's clearing off that edge over there. Now instead of continuing on to this wall over there at that 5 millimeter step down, it's going to do the following. It's going to go up and jump over to the other side. So in essence, what's happening is you're always having an even amount of pressure on either side of the wall as you're going down on the part. Now the first step is not as critical as you go further down. So right now we go practically up until the wall itself, until the actual offset that I left over there. Now as I continue down, it goes down now to the next step. Now in this next step, look what happens. It's going to do exactly what it did before, but this time, note, it didn't go all the way to the end over here. Instead, it went back out over here. So we actually have now more support towards the wall. Now, as we go down, let me actually run this all the way, running it slow. As you see, as it's going down, it's clearing away these steps, going further and further in. Let me stop it for a moment. And you can see it had that step moment. Now, it went, as it finished off this area over here, it started again from the top. Now it went down up until this wall over here. And the same thing on the other side. Again, giving those steps. So this way you always have support on the wall as you're going down that thin wall. This way you get the most support you can possibly get on those thin walls. Now I still have to finish this. To do that, what I'll do is very simple. We'll exit the operation itself. I'm going to do save and copy. And same tool, same geometry, same levels. But now let's go to our technology. First of all, I'm not going to do a wall offset. I'm going to keep that at 0. Next, I'll keep my step down the exact same way it is right now. But this time, instead of alternating steps, I'm going to use the option of supporting steps. Now, supporting steps doesn't work on excess material. You see now the clear offset is grayed out. And let's run our simulation and we'll see exactly what happens. We'll do this one step at a time. Now the first thing you'll see right now as I zoom in, you see we have the excess of 0.5 millimeters on either side of the wall itself. Now what's going to happen is as follows. The first step that it goes down to is going to be 2.5 millimeters. Not 5 millimeters, but half of that. It goes across, machines that, fine. Now when it goes to the other side, now it's going down to its full 5 millimeters. Now note, when it goes down to this full 5 millimeters, it still has 2.5 millimeters of support over here. So you still have support on the other side of that wall. So you're not completely on thin grounds over there. Now, as it goes down to this side, now it's going to go down 5 millimeters from here. When it does that, again, it cleared for 5 millimeters of material over here, but it had this amount of support on the other side as well. And that works all the way down to the very bottom up until it gets to the floor. Once it gets to the floor, after that 5 millimeters, it has 2.5 millimeters on the very bottom on the other side to clear away. And that finishes off that entire wall over there. That's actually probably the best way to work on thin walls. And this is done now all in a very simple operation. Okay. Now, one more operation I'd like to do is as follows. We have these round pockets over here. The perfect way to machine a round pocket is once you helical in, and once you helical into the pocket itself, you do an actual spiral cut on the floor to get the most efficient cut you possibly can. Since it's a perfect round pocket, we have a specific operation made just for that. If I go into ToolBox Cycle, we have the option over here called Spiral Pocket. Choosing the spiral pocket is very simple. The geometry, adjust the actual arcs themselves. The first one, the second one, the third one, and the fourth one over there. That's my geometry. Let's use a tool. We'll use a 6mm end mill for this. Okay? We have our levels. Upper level in this case is over here. And my depth is up until that floor over there. A total of 8mm in depth. In my technology, we have the following. How much do I want to step down each time? And once it does a spiral cut on the bottom, what's my minimum and maximum cutting angle? I have full control of that over there. I also have my helical angle. What's the actual angle I want of my helical angle as it goes into the part itself? If I want, I can do a wall offset and then finish the wall. Same thing with the floor. Let's just do a simple simulation, exactly the way I have it here right now. And we'll see the following. We'll see that the tool, I'll do this one step at a time, goes into the part. It's actually starting to helical into the part itself as shown over here. You can see that happening over there. Okay, now once it gets down to its level, the first 3mm, then it starts doing a spiral cut. Now let me get rid of the solid so you can actually see the actual tool path a lot easier. And we'll also look at this from the very top view. You can see now, when it does that helical cut, the spiral cut on the floor itself. You can see it's a spiral, it's a constant tool path. And if I turn it to the side, you can actually see it going in using that helical toolpath, and it's doing this on all of the pockets, all of the circular pockets as shown over here. Very easy to actually program this way. Simple but efficient. Okay, that's basically the end of the webinar. This has been recorded, so it will be available on our website together with the parts itself. So everyone take care. Have a great weekend.